Okay, let's get started for today's session, week number 6, lecture number 1. And just a quick recall, we were looking at composition. You also had a lab session on this topic on Friday, right? So today we'll try to wrap this topic up maybe in the first 20-25 minutes. I'll just do a couple of more examples. And then in the last 1 hour, we'll be looking at some other topic, right? So just to revisit, composition is an important concept in object-oriented programming, and composition represents has a relationship, right? When you want to make a class, you want to reuse the existing classes, right? So we had done plenty of examples from the discussion point of view, and then we had programmed 1 or 2 complete examples, right? So whenever you are solving a problem, it's not, you can say, a smart idea that every time you start making a class from the scratch, right? First, you try and reuse whatever is already there. So an example that I had discussed with you in the last week was that when you are maybe designing a management system for an organization which has employees and staff. So, for example, if you want to store their data, maybe you will need their date of joining, their date of birth, and so on. So instead of writing them from the scratch, if you already have a class called date, you can reuse it, right? Similarly, if you want to keep track of attendance of the employees, that at what time they arrive at the office and at what time do they leave. So again, if you have time class, so you can take 2 objects of that class, where one is the time of arrival of the employee, and the other object could be the time at which he or she departs, right? So the core idea of composition is reusing the existing classes, and composition represents has a relationship, right? When we talk of UML, we said, okay, you can represent composition with a diamond, right? And diamond is placed on the towards the side of the container class, right? So if we say student has date of birth, so we'll put the diamond towards the student class. Okay, so this was just a revisit of previous discussion. We had started an example of a rectangle class, but I had not programmed it, right? We just discussed it. So let me just remind you that we were saying that if you want to maybe model a rectangle, then there are different ways, but one of the ways is that you can keep 2 points. One point is like the top left, and the other point can be called, say, bottom right. And every point has x coordinate and y coordinate, right? For example, when you talk of this point, so it is something, say, maybe it is 2 8, and similarly when you talk of this point bottom right, so maybe it is like 10 2 or anything, right? So since we can perfectly take 4 integers in the rectangle class, right? X1 y1 x2 y2, that is perfectly okay. But if we already have a class point, so it makes sense that we can reuse that class. Okay, rather than taking 4 integers, a smart choice would be that I can take 2 point objects, because every point has x and y. So I will be able to reuse the functionality which is available in the point class, right? So we had done this discussion, but we had not written a program. So let me write the program, and maybe I can directly write it on the Visual Studio rather than here, because we have already discussed it in quite some detail. So let me just write this program. Okay, so if you remember this I have not changed from the previous time. This is the class point which has been there since the very beginning. So let it be there. And let's extend this program to see a working example of composition. Okay, so what I'll be doing, I'll be adding a rectangle class to this program. Okay, so since I have to show you the screen, I'm doing it in the same file, right? But if you do it in a lab session, so it's a good idea that you do it in a separate file, right? Rather a separate H file and CPP file for every class, right? But since I have to share the screen with you, and I want everything to be available on a single screen, so that's why I'm writing this class within the same file, right? Okay, so this is class rectangle. We have some data, we have some functions. So as we said, we will model the class with 2 points. So instead of taking 4 integers, I take 2 points in this class. Okay, one point I call top left, and the other point I call bottom right, right? So these two statements which I have written, these two definitions, right? So this is actually composition, because in one class I have object of another class as a data member. Rectangle has point, right? So I'll also show you the diagram for this later on. So now we can maybe write some functions, right? So the important function is constructor, which is same name as name of the class, right? And sorry, and what we will doing is that it will be accepting 2 points as input, right? So we can write point maybe top left and point bottom right. And what we can do, we can say top left gets the value of this top left, and bottom right gets the respective value. Okay, then if you remember, I also told you that when you are making a print function in a class which is using composition, so you have to be careful, right? For example, there's a temptation that especially when you are writing on a paper, so many students tend to do this mistake, right? They would like something like this. Okay, so you see, because on the compiler you will instantly get to know there's some problem, but if you are writing on the paper, so in maybe quickly many of the students lose concentration and they quickly write cout and an object, right? So this is not allowed. We cannot use this operator with object. So what we'll be doing is, since we already have a function to print a point, we will call that function. Okay, and how do we call it? When we want to print the top left point, so maybe I can write cout top left. Okay, and then I can call that function, and the function is name of the object, which is top left dot, and after the dot we have this function print point, so I can call this function. So now you see, the function is in the point class. So from this class we are calling a function of another class, right, which will print the x and y coordinates of this point, which is top left. Since I also need to print the coordinates of bottom right, so I will again write the same thing but with a different object. Okay, so now this is our rectangle class print function, which is simply printing the top left and bottom right by calling the print function in the point class, right, with the correct object. Now let's just do till here, and then I will add some more functions, but just maybe we can first run the program till here, and then we add more functionality to this class. Okay, so maybe we first create 2 points, top left. Okay, so top left is maybe like x is 2 and y is 8. Okay, just like we were drawing. Bottom right is maybe x is say 10, y is 2. Okay, so it would be a similar rectangle which we drew on the board. Okay, and now once I have 2 points, now I can create an object of the rectangle class, right? So I can write rectangle R. Okay, and I will pass it 2 points. Okay, so this top left will actually go into this variable top left of the rectangle class. Similarly, the bottom right, through the constructor, we are passing it to the bottom right. Okay, so let's just print this rectangle just to see if everything is fine. So we call its print function r dot print rectangle. Okay, let me just compile and see if it's fine before adding some more functionality to this class. Okay, so let me share with you the output window. Right, so I hope you can see the output window where we are printing the data of a rectangle, which actually comprises 2 points. So the top left is 2, 8, bottom right is 10, 2, right? So it seems to be working fine. Okay, so let's go back to our program and add more functionality to this class. Okay, so if you remember the previous discussion, we said, okay, maybe we are interested in computing the width and height of the rectangle, right? So if this is the width, right? So how do you compute width? From x, you subtract x, right? So width is actually 10 minus 2. Similarly, if you want to compute this height, then from this y, which was 8, you subtract this y, which was 2. So 8 minus 2 is 6. So 6 is actually the height and 8 is actually the width. Okay. So we'll be using the same concept and we'll be making two functions in the rectangle class, which can tell us the height and width of the rectangle. Okay. So let me just make two functions. One is say int calculate width. Okay, and the other one is int calculate height. Since height and width are integer, so whatever I will calculate, I will return from this function. Okay, you see, it's a good idea that return a value rather than simply displaying it to the user, because if you return a value, you can reuse it in some other function or even the main. Okay, so many of the you can say students in the big when they are beginner in programming, so they say, okay, I will calculate width and I will see out it, display it. That's perfectly okay, there's no problem with that, right? But then if you need width in some other function to compute something else, then you see you will not be able to do that. You will have to repeat the code again. So it's always a good idea that whenever you are doing some computation, return that computation from that function. Okay, so now what would be the width? Width would be, right? So you see, we have to subtract the x coordinate from the bottom right. From the bottom right, we subtract the x coordinate of top left, right? Just as I explained you on the board. So bottom right dot. Now you see, I cannot directly write dot x because x is private data member. I cannot access it. But luckily, we made these functions get x and get y. So we'll be using these functions, which will actually help us access the x and y coordinate of point, right? Because outside the class, we cannot access private. That's why you cannot write bottom right dot x. If x were public, okay. But normally we don't keep data public. So we'll have to use this function. Similarly, for top left, you will have top left dot get x. Okay, so this will give us the width. Okay, we are subtracting the x coordinates, so we'll get the width of the rectangle. Similarly, if you want to get the height, you will need to subtract the y coordinates. So I will write return top left because it is on the top, so I call get y minus bottom right dot get y. Okay, so now with these functions, I hope we should be able to compute the width and height of the rectangle. Okay. Now let's just add one more function that maybe we also want a function to calculate the area of a rectangle, right? And area of a rectangle is its width into height. So let me add another function, calculate area. Okay, so I will make it here, int calculate area. Now you see, since I already have functions to calculate width and height, so what I can do, rather than computing them the width and height again, I can simply call those functions. So I can write return calculate width, which will give me width, multiply by calculate height, which will actually give me the height of this rectangle. Okay, so this is just to again reinforce that from one function of a class you can call any other function, right? So rather than repeating the code for computing width and height, I'm simply calling the functions. So I get the width and the height and then I return it. And let's now, okay, try to print the area of rectangle in the main. So I say area of the rectangle is, okay, and what is that area? You can actually call that function. So I will write r dot calculate area end line. Okay, so we expect it to calculate width and height and give us the area. Okay, so let me compile this program to see if everything is fine, and if it is, let me just also share with you the output window. So now on your screen you can see the output window. We have 2, 8 and 2 as the rectangle. You see the width was 8 because 10 minus 2 is 8. Height is 6, 8 minus 2 is 6. And the area is 8 into 6, which is 48. right? So area of the rectangle is 48 meters square, centimeters square, whatever you want to call it. So now we have confirmed that, okay, using composition, we were able to solve this problem by reusing our point class rather than writing everything from the scratch, right? Let me just add some more details to this program. So the important part in this, you can say, discussion was, first was the, you can say, this print function, right? That when you are printing, please do not write cout directly with the object. You have two objects within this class, so you will use the dot operator and call the print function of those methods, those objects, right? Similarly, another important, you can say, point was that when you are in a main, so of course, first you will be creating the objects of the contained class, right? This was your contained class. And then you pass them to the container class, which is a composite class, and then you can call any of its function. If you want to represent it visually, so we said this is my rectangle class, this is the point class. For composition, you use a diamond, right? And diamond you put towards the composite class, right? So if you want to visually represent it, it would be something like this, that you can have two rectangles which are connected and the diamond is drawn towards the container class. Okay, now let's see a few more real world situations, right, where composition can be very helpful for us, right? So we discussed them in the previous week as well, but I just discuss them more formally. That you see, now let's take a different example rather than maybe point or rectangle. Let's take an example from a real world management system or scheduling system or something like that. Okay, so if you remember last time I had given you an example of exam or flight or maybe some terminal at a bus station or something like that, right? Where you have a display board on which you see the schedule of different flights and so on, right? So you see, whenever you are talking about things like maybe a flight or an exam, right, or an event, right? It's a dinner or it's a conference, anything. So for all of these, you see, or anything that you can think of, uh, you see normally there are critical parameters like what is the date of event or flight or exam, what is the time of event, and date itself can be basically if it is spanning multiple days, so there can be more than one date object. Similarly, time can be start time, end time, break time, you see. So there can be many different objects within the same class. So let's see how we can actually solve some problems. So you see, these date and time, these are very typical classes. Means you can just make them once, save them somewhere, and you will be reusing them a lot. Okay, so you already have a date and time class in your lecture slides as well. So it's a good idea, you just make them, you keep them safe because you will be reusing them many times, right? Now suppose we have these classes available, and now if I am making a class for the flight, okay, so I will reuse this class. So I will say, okay, flight has some time, flight also has some date. So we can use composition, we can reuse this class. So it would be something like that. Now when you have an you can say event class or exam class, so again you will be having something like exam has a date and exam has a time, rather time of start, time of end, and so on, right? So it would be like this. Similarly, the same date class, not maybe time, if you have an organization in which you have different employees, right? So for employees, we need their date of birth, date of joining, and so on. So again, so now you see this date class in even we are only in the fifth, sixth week of the semester, and we can see how much reusability we can have, right? All of these are different programs: flight management system, exam management system, and an employee management system. But all of them can reuse this date class, and some of them can also reuse the time class, right? So an important, that's why an important design level decision is that whenever you are making these classes which will be reused, okay, so I told you this last time as well, so please keep these classes, I use the word clean, right? Clean means that if in a date class you have some functions, those functions should only be relevant to a date object. Function you have in the time class, they should only be relevant to time. You should not add any functionality which is dependent on flight, right? Similarly, you should not add any functionality in the time class maybe which is dependent on exam, because if you do that, um, it means that then the reuse will be limited, right? And what is a common, you can say, not a mistake but a common sloppy design that many students do, that suppose I give you the problem of modeling an examination management system. So when some student is making the date class, so what he or she will do that in the print function, right? Since they know that I am making it for the exam class, so he or she will write C out exam date, okay, and then he will write C out day, month, year. Now, since this first line is dependent on the exam class and you have added this cout statement in the date class, so it means you are using some information which was related to exam class in the date class. Now, if someone is reusing the date class in the flight and he or she is calling the print function, so what he will see exam date, but it is not exam date that we are printing. We are printing the date of flight, right? So that's why it's a good idea that always think big, that when you are making the class, it should be clean in the sense that it should not have some information that is dependent on some other class, okay? So I'll not make the complete program, but just to give you an idea, maybe I'll make some blank classes, and whatever we have made in terms of diagram, let me just convert it slightly partially into code, right? So maybe you can have a class date in which you can have some data. I'll only write data, right? And day one, sorry, and year, right? You can make other functions, everything else in the class, right? Similarly, you can have a class like time, so, right, where you have, okay, so you can have like into hour, minute, and second. Okay, similarly, you can write functions in this class, and now you see I can make a flight, say class flight, private, public, and here what I can do, I can now say date, say date of departure, one object, date of arrival, time, time of depart, time of arrival, and int flight ID. Okay. So now you see, this is a very good example of composition where you have a flight class which is reusing two objects, or reusing the date class by making two objects of the date class, right? And similarly, you have two objects of time class and then an integer which is flight ID. Okay, this is okay, right? But you see, it in some cases it is also possible that here I only need it two times. But suppose if I need more than that, or in some cases, if right, instead of writing this, it is also possible that I can take an array of time objects in this. Okay, these are two times, and I say, okay, T0 is time of departure and T1 is time of arrival. So it will still be an example of composition, right? Because we are taking two time objects, we can take separate objects like independent variable, or we can also take an array. That's perfectly fine, right? So please do remember, if you take an array, or you can say individual objects, it will still be an example of composition, and this flight would be a composite class. Okay, so with that, I'll conclude composition, right? So if there are any comments or questions, we can discuss those. Thank you.